So the last thing with chapter 7 then is we have a few fiddly little bits to deal with. Now, first of all, in this video I will talk about the difference between a one-tailed test and a two-tailed test, and also we'll talk about actual significance levels. But a bit of advice first of all. One of the reasons that people find significance tests difficult is just the grammar of giving you a definition of what a statistically significant result is quite difficult. Actually, framing the sentence is quite hard. I'd really advise for chapter 6 and 7, you try and sit down and write down a definition of a random variable, a probability distribution, a description of what a hypothesis test is, a definition of what a statistically significant result is. If you can frame those sentences in a way that makes sense, then you basically must have understood the ideas. Now, I would advise you to try and learn this and then stop this video and do that for yourself. But just to sort of spoil it, here's my efforts. There's no neat way of doing it. That's kind of the whole point. So I've written this down. I'll read it because my handwriting's so terrible. But if you have a statistically significant result, then that means if your null hypothesis is true, then the result is so unlikely that it happens less than 5%. I put 5% in brackets because the 5% is the significance level. Okay, so at the 5% significance level, a statistically significant result is something which, if H0 is true, then it happens less than 5% of the time. Therefore, we're going to reject the idea that H0 is true. We're going to say we don't believe that anymore. Or another way of putting it, if a result is statistically significant, and that means the probability of it happening by chance is less than 5%. It could happen by chance, maybe it happened by chance, but the probability of it happening by chance is less than 5%. Therefore, we don't think it did happen by chance. We chose 5% as a small enough probability to say, well, if anything so unlikely as only to happen 5% of the time happens, we're not happy with our initial assumption. So the probability of happening by chance is less than 5%, therefore we don't think it happened by chance. Okay? One other little footnote is you either have a significant result or not a significant result. There's no room for sort of saying, well, it was nearly significant, it was close enough. The whole point of having a hypothesis test is to give you an answer that says this is significant or this is not significant. Now, that's not to say you can't do another hypothesis test. If you do a test, it's quite possible that, and I'm saying possible, it doesn't mean it's likely, but it's quite possible that you get an unusual result. You get the time where you flip a coin 100 times and you do get 100 heads in a row. And if you get a result, whether it's significant or not, it can often be a good idea to try and replicate that result, try and make sure you're getting the same result on other experiments in other situations. Make sure that for some reason your experiment wasn't biased, and that is just getting more and more good evidence in favour of whatever the result is that you've got. If sometimes you get a significant result and other times you don't get a significant result, then you maybe need to examine the way you're doing the experiment, the sample size, the methodology, some of your assumptions. Maybe you need to change the significance level, or perhaps not the significance level. Maybe you need to change other things about your experiment and look at the wider picture of your whole statistical process. But what you should find is that, if you're making an assumption that, for example, I have a new headache pill and I think it works better than paracetamol. If I'm correct, then it will consistently work better than paracetamol. If I'm incorrect, it will consistently not work better than paracetamol. Okay? If I test it on enough people, I should understand the truth. If I flip a coin enough times, I should be able to find, beyond any sort of reasonable doubt, whether it's a fair coin or not. That's the idea, okay? If you flip it 100 times and you're not convinced, you are welcome to flip it another 100 times and another 100 times and another 100 times until there is enough evidence to be convinced by, okay? Strictly speaking, just as a sort of technicality, you could flip the coin 1,000,000 times, get 1,000,000 heads in a row, and there is technically a non-zero probability of getting 1,000,000 heads in a row on a fair coin, but practically speaking, we are absolutely convinced by that. And this is again the thing that scientists are saying a lot, which is we have evidence to support the idea that when you hear a scientist, a good scientist, a reliable scientist saying there is scientific evidence to support the idea, what they really mean is we're absolutely convinced that's true. But because scientists have had training in this idea of statistical significance, There is that, it is a technicality. If you flip a coin 1,000,000 times and you get 1,000,000 heads in a row, there is absolutely no room for doubt, really, that is a fair coin. It's just that we're aware of this idea of statistical significance, that theoretically we can never 100% prove it, but we can prove it to so close to 100% that it makes no difference. Okay, now let's get back to this idea then. One-tailed tests, two-tailed tests, and actual significance level. So first of all, let's have a look at this actual significance level. Let's say our critical region, let's take the example here, and here we've got what looks like obviously a binomial situation, because we always have binomial situations. We've got a peak at 4, so the probability of getting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 10. 4 is the highest probability, and then, as we'd expect, the probabilities dip away from 4 either way. Now, the critical region here is 8 or 9 or 10, okay? So if we get a test statistic which is 8, we would reject H0. If we get 9 as a test statistic, we'd reject H0. If we get 10 as a test statistic, we would reject H0. Now, what we'll find is the probability of getting 8 or more is not actually 5%. We want it to be 5%. We want a 5% significance level, but the probability of getting 8 or more is 0.0123. Now, if you look at that, that is a 1.2% significance level. But we said we wanted 5%. We've got 1.2%. Well, those numbers seem to be quite different. Why can't we say, well, we'll put 7 in there as well? Well, if we take the probability of 7, then that is 0.04. So probability of getting 7 or more is 0.0425 plus the probability of getting 8 or more, which is 0.0123. So that is 845. So the probability of getting 7 or more is 5.48%. Okay? Now that is bigger than our 5% significance level. Now you might think, well, hang on, we wanted a 5% significance level. 7 or more gives us a 5.48% significance level. 8 or more gives us a 1.2% significance level. So this one is closer to what we wanted. The rule that we follow is your critical region is allowed to have any significance level up to the level asked for, anything up to 5%, but it's not allowed to go over, okay? So in this case, the critical region would have to be 8, 9, or 10. It can't be 7, 8, 9, or 10, even though if we were asked for a 5% significance level, 7 or more would be a lot closer to it. The actual significance level is the probability of being in the critical region. So that is, in this case, 1.2%, okay? Now, be a little bit careful, because there are some questions which are worded a little bit sneakily. If they say do a 5% significance test, then you do exactly what they've done in this example. You would have an actual significance level of 1.2%. There are 1 or 2 questions where they say have a significance level as close to 5% as possible. Well, as close to 5% as possible is this one, is 5.48%, okay? So if they just say a 5% significance level, then you need to be 5% or less. You're not allowed to be more, even if you think it would logically make more sense. But in order to be a bit sneaky and ask some nasty questions, then in this book, and I think on some of the exam preparation material, they have that phrasing of the question as close to 5% significance level as possible. So that's the first thing. Your actual significance level is obviously not going to be always 5%, and it's sort of obvious when you think about it. There's no reason that a certain number of these probabilities should add to exactly 5%. The next idea is one-tailed and two-tailed tests. So first of all, one-tailed tests. Our null hypothesis, if we're dealing with a binomial random variable, which we always are in this book, the null hypothesis is that the probability equals a certain number. The alternative hypothesis, if the question says something like, so the doctor claims the new drug represents an improvement on the standard treatment. So we'd say the probability of somebody being cured would be an improvement according to this doctor. Then that would be, we're interested for our null hypothesis in saying, is the probability bigger than that particular number? We could have something like, something where we're expecting does this represent at the significant evidence at the 5% level that the probability of a 6 on the dice is less than 1/6? So if the probability on the dice we think is 1/6, if we have reason to believe that it might be less than 1/6, then we can ask the question, what's the probability of being less than 1/6? And then the critical region, instead of being, oh sorry, that's a terrible diagram. Here's my general binomial shape. It doesn't have to be symmetrical. The critical region will be down here somewhere on the left-hand side. If we're interested in the probability of being bigger than, then the critical region will be up here on the right-hand side. Okay, so these are what we call one-tailed test, because here are the tails. The critical region is sort of the tail ends of the distribution. If you're only interested in what's the probability that, if you're interested, in this probability being smaller than we thought, or interested in this probability being bigger than we thought, then we use a one-tailed test. We look just at this end or just at this end, and the critical region is 5% down here or 5% up here. Okay. Now, if you look at all these questions in exercise 7c, because this is the one-tailed test exercise, something in here will give you a hint. So question 9, look, it says the horticulturalist believes that this new technique will improve the number of plants. There's the word improve there. She thinks that the probability is increased. Okay. If you look at two-tailed tests, then in these tests we don't know whether the probability should have gone up or it should have gone down. We have no suspicion. We're not interested in saying has this got better or has it got worse. We're just interested in the question of has the probability changed in any way. Okay. So let's have a look at question 8 and let's see if we can find the part where it tells us that it's a two-tailed test. This machine makes glass bowls and it's observed that 1 in 10 bowls have a hairline crack. The production process is modified and a sample of 20 bowls is taken. One of the bowls is cracked. Test at the 10% significance level. The hypothesis that the proportion of cracked bowls has changed. It doesn't say test whether the proportion of cracked bowls has increased. It doesn't say whether the proportion of cracked bowls has decreased. It says has the proportion of cracked bowls changed, in which case we want a two-tailed test. And if we've got a two-tailed test, what we do is we take our significance level. Let's say it was a 5% significance level. We snap it in half. And we look at a tail down here and a tail up here. So the critical region is in two parts. There's the lower half of the critical region and the upper half. I should say the lower part and the upper part. There's no reason for them to be the same size necessarily. If we've got a total significance of 5%, then it's 2.5% down at the bottom, 2.5% up at the top. And remember, not more than 2.5% here, not more than 2.5% here. Okay. Now, if you don't like that, if you think that that means that, if you think, well, I want a tail to have an area of 5%, well, in that case, what you need to do is you need to do a two-tailed test with a significance level of 10%. And it's up to you as the person carrying out, in the real world, as the person carrying out the test, you can pick your own significance level. As long as you make it clear in your write-up what you've done and why you've done it, it's then up to other people to say whether they're convinced by your evidence. So if you pick a bigger significance level, maybe your evidence is less convincing that you've got a significant result. If you pick a small significance level and you've got a significant result, that's pretty convincing. But on the other hand, you might miss what somebody else would call a significance level, because a significant result, because your significance level is too small. So two-tailed tests, you take your significance level, usually 5%, snap it in half, a tail down here and a tail up here, two parts of the critical region, and 2.5% and 2.5% up here. The probability of these sticks and the probability of these sticks adds up to 2.5% at most here and 2.5% at most here. Okay? And that is everything on that chapter.